Okay, so in this problem, I got a wood beam loaded as shown. Let's see here. It wants me to find basically B so that I don't exceed 0.7 megapascals in stress. So the first thing I need to do, again, my equation that's going to kind of govern everything for transverse shear is VQ over IT. The first thing I'm going to do is figure out where the maximum V occurs, okay? And again, first thing I need to do is kind of do a shear diagram, okay? So I got to find those reaction forces like so. So I'm just going to quickly do that, summing the moments about A, just doing some statics here. I get, let's see here, main span is 3.6, and then I got you. Okay, so that's occurring at, that'd be 1.8, and it's a negative. So 1.8 times 3p. P is, okay, 5, so that's going to be 15. And then I have B, which is plus 3.6 times B, and then minus, that would be 4.8 times 5 equals 0. From that, I learned that B equals 5 point, nope, wrong one, 14.167. Okay, now I've got 20 going down. That means I have to have 20 going up. Therefore, A equals 5.83. Okay, so if I draw my shear diagram, it looks something like this. That's V. This will be X. Again, I start at 5.83. Okay, then I drop down 14.67, so that actually drops down like this to, that would be below, which would be 9.167. Come back here, and it pushes it up 5 to, no, not 5. Pushes it up, hold on one second. I'm sorry, at B it pushes it up the 14.167, which pushes it back up to above it at, oops, hold on one second, pushes it back of it at about 5, which it comes over and back down 5. So the maximum shear as far as a magnitude goes is going to be right there at 9.167. Okay, so that's where the maximum shear is. Now, as far as Q goes, maximum Q is going to occur at the neutral axis. So I'm looking at this area right here, which is pretty easy to deal with, right? Because Q, of course, is y bar prime times a prime. So the location of y bar prime is going to be 70, right? Because it's half of half, right? So half of 140, which would be 70. Okay, that area is then going to be 140 times B, so 0.14 times B, which gives me a Q equal to 0.0098 times B is what Q equals. I, well, that's just the moment of inertia of a rectangle, is going to be 1/12 B and then H cubed, like so. And again, I don't have to do a parallaxis theorem because it's at the neutral axis. It's a rectangle, very simple. That gives me I, which equals 0.00183B. Okay, and the thickness is, of course, B here. Okay, so plugging everything in, knowing the allowable shear stress is 0.7 times 10 to the 6th for megapascals equals V. And again, we found V equals 9.167. Well, in That's in kilonewtons, if I'm not mistaken. So then in newtons, that's going to be 9167 times Q, which is 0.0098 B, divided by I, which is 0.00183 B. That will be then times another B. So I have this equation. I can solve it for B, and I find that B has got to be 70 millimeters for this to hold, for it not to exceed 0.7 megapascals. Okay. So again, the first thing to do is find where the maximum shear is occurring. Once I have that, then I can just do that the maximum shear stress occurs at the neutral axis, so use Q, I for the whole thing. When that all comes down to it, you can go ahead and solve for B and get your answer that way.